Thank you so much. Welcome, everyone, and thank you for joining me on my journey to story-based releases. This is an experience report on how the last couple of years I worked on a project that was absolute chaos when I started, where the Git main branch was continuously broken, where up until the day before going live, all of our environments were down. So basically, I was pulling my hair out in frustration at this project. But it ended up being the best project that I've ever worked on so far. But before we dive into that, allow me to introduce myself. My name is Mazin, and I was born and raised in the Maldives. For those of you who don't know where that is, you'll have to zoom in on the Indian Ocean in the map, and you probably still won't find it, because it's very small, but it's there, believe me. So when I was 13, 14, I moved to the Netherlands, and there I discovered programming on the graphical calculator. Do you guys have those everywhere? Yeah? Cool. So this is where my passion for automation actually began. But being a teenager, I didn't realize this, so I went and did something entirely different. I studied aerospace engineering in Delft, but then realized I should do something more with automation. So luckily, I found my passion for automation again when I rejoined Capgemini as a test automation engineer, and since then I have set up test automation for several projects, and I am a trainer at the Capgemini Academy where I give courses related to test automation. So due to my test automation knowledge, I was asked to come in and set up test automation for this project. And today I want to talk to you about my journey from absolute chaos to the best project that I've worked on so far. I want to talk about how there was no testing done before a feature was merged. I want to talk about how I delved into the world of Kubernetes, GitLab pipelines, and Helm charts, so ops, but always from a quality perspective, hence the term TestOps. But most of all, I want to talk about how the client wanted to be flexible. You can come in. You can come in. They're staying outside, but there's a, yeah. So most of all, I want to talk about how the client wanted to be flexible and to have the ability to release often, and how this led to a process enabling story-based releases. Now, I am a huge fan of fantasy books. Any other fantasy bookworms here in the room? One or two? Okay, not that much, so I hope the jokes that I have in here are going to fall well. We'll see. I've structured the rest of this talk as if we're navigating through a fantasy epic. So, you know, like the quest of adventurers setting out on an epic journey, it's not going to be smooth sailing from beginning till end. We faced many challenges, and every challenge we faced and survived only to face a new challenge. So, yeah, that's why the first chapter is titled Out of the Frying Pan and Into the Fire. Now, this is a reference to the book The Hobbit, and in this chapter, Bilbo and the dwarves narrowly escape the goblins in the Misty Mountains, only to find themselves being chased by wargs, evil wolves. So they climb up into these trees to escape the wargs, but then the goblins come and set fire to the trees. So they find themselves in an even bigger problem than they had before. And this is how it felt for me at the beginning of this project as well. We had so many issues, and every time we would solve an issue, we would find ourselves facing an even bigger issue. Now, it all started when I was asked 2 years ago now to come in and set up test automation for this project. And to give you a bit of context, the project was about multiple websites with a microservice architecture. So each front end consisted of multiple micro front ends, and we had a back end consisting of microservices. Now, each micro front end or each microservice had its own Git repository. So let's call them components from now on. And you needed all of these components together to have a working application. And I soon realized that setting up test automation, you can do that quite quickly. But how does that fit into the development process? So I started asking questions. So what's your development process look like? And then I realized we had even bigger problems. So let me tell you a bit about the development process. What would happen is a developer would write code, and he would push that code to the main branch of that component. And that push to the main branch would then trigger a deployment of that component to the test environment. Only then would testing come into play. And guess what? They'd find bugs. It was broken. Now, imagine a situation when you have over 30 developers spread out over 4 teams working on all of these components. It wouldn't be clear what had broken the test environment. Which merge actually broke the test environment. So an analysis had to begin to figure out, okay, what broke it, what's the actual cause, are there multiple causes, and how are we going to fix it? But in the meantime, the development work continued. Headaches. I had headaches about this for days. Anyway, like I said, the client wanted to be flexible, and they wanted to be able to release often. But with this way of working, we're never going to do that. We could never release with this way of working. Luckily, this project was open to experimenting. And that's what saved our asses. So we started in experimenting. We thought, okay, let's figure out what we can do first. The first thing we said was, okay, so before we merge that code into the main branch of a component, what if we spin up that component locally and test it locally, in isolation? Sure, sounded good. We tested it, we found some bugs, fixed those bugs, awesome. But guess what? Once we integrated it into the system, it still broke, because integration tests weren't there. Okay, so then we thought, what if we then spin up the entire application locally? So guess what? Everyone has different machines, different laptops, different OSs, and we literally ran into issues of it works on my machine, because, yeah. So we were falling from problem to problem. So we were now facing even bigger issues here. And we needed to get out of this cycle of out of the frying pan and into the fire. So we find ourselves at the beginning of our journey. We are in need of a proper development process that works for all 4 teams so that we won't keep on breaking the environments. And I've marked our journey on this map where each chapter is an icon that you can follow with me so you don't lose yourselves in this fantasy epic that people don't read now, anyway, I think. So, yeah. We'll see. The first leg of our journey is the Council of Elrond. Now, the Council of Elrond, I don't know how many people here know Lord of the Rings. It fits my chapter perfectly for multiple reasons. Not only does the Council of Elrond mark the beginning of the journey of the Fellowship of the Ring, but the Council itself is split up into 2 parts. First, there's a bit of storming. Everyone has ideas about what to do with the ring. We should destroy it. No, we should reuse it ourselves. You know, everyone has ideas and input. And in the second part of that council, they actually come together and align towards their common goal, and they form their fellowship. And that's what we're going to do in this chapter as well. We are going to do a bit of storming, and then we're going to come together and align towards our common goal, namely that the client wants flexibility and the ability to release often. So that first part is test strategy storming. This is something that I picked up from a colleague of mine from Capgemini Germany, Katrin Potzar, and she based it on event storming. Basically, it boils down to bringing the right people together and to focus on creating a common understanding of everything that's related to testing. So once you have everyone together, you focus first on the test stages. So what stages do we have? Things like unit testing, component testing, contract testing, integration testing, end-to-end testing. I don't really care what the names are that you use here, as long as everyone involved has a common understanding of what each test stage stands for. Once you have those test stages determined, you can then look at the test types. So things like functional testing, performance testing, security testing, accessibility testing, whatever is important for you. We actually did a bit of risk storming to figure out which test types were important for us. Now, once you've figured out your test stages and your test types, you can now start filling in this matrix. For each cell, you then fill in which roles are going to be involved, which metrics are important, which tools you're going to use, and on which environment you're going to run these tests. And if there's anything that's unclear at that moment as well, you write that down so that you can look into it later. So once you fill in this entire matrix, you'll see that you now have a clear understanding of everything that is related to testing. Some cells in here won't be relevant, but you now have a common understanding of everything that's relevant for testing. But then you'll need to figure out, okay, but when are we going to do the testing work? And that's where the second part comes in. And that's what I did with value stream mapping. Now, value stream mapping is something I picked up from a safe DevOps training, but value stream mapping itself is, in theory, about calculating the amount of time you spend in a certain stage of your process, the amount of time that, the lead time for that stage. So basically, you calculate the efficiency of your development process. But we didn't have a development process. So I thought, okay, what if we take the theory from value stream mapping and figure out what our ideal development process would be? So once again, we got everyone together, and we focused on creating this common understanding. So we sat down and thought, okay, what are the steps that we need to do from the moment that an item comes onto our backlog all the way to bringing it up to production? And in which order are we going to do these steps? And when we set up this order of these steps, we kept in mind, we want to be flexible, and we want to be able to release often. So for me, that meant basically that our main branches needed to be able to go to production all the time. They needed to be stable. So I argued that our testing should happen as soon as possible. Shift left. That's something that shouldn't be new for you. You've all heard about it. That meant that looking at all these test stages and test types that we determined earlier and figuring out, okay, what's the first moment that we can test these? What's the first moment that we can implement this in our process? I got into an argument with the architects here about that they didn't agree with me on shifting left here, but I don't have enough time for that story. That's too long for now. Maybe if you have questions at the end. Anyhow, so we determined our development process, our ideal development process, using this value stream mapping as our theoretical background. And we discovered that we decided that we wanted to have dev environments per team. We wanted still to have a test environment where the main branches would be deployed to, and we said we needed an ACE environment and we needed a prod environment. Sure. Now, once again, I really don't care about the naming of these environments, as long as everyone involved has a common understanding of what each environment is going to be used for. Because we did most of our testing work on those dev environments. And the test environment was where the main branches came together, where the merges happened, and we only ran a simple regression test there. And the AC environment was where we did our end-to-end tests with our external parties. And of course, we had production. But anyway, this is what people were comfortable with at our company. So, you know, what's in the name? So, at the end of our council of Elrond, we now have a development process that works for all teams. We did this by using test strategy storming to figure out what's relevant for testing, what are all the important facets for testing. And we use value stream mapping to come up with our dev process. And now with our fellowship formed, we can continue on a journey towards story-based releases. So as soon as you start implementing a new process, you'll run into issues. And this chapter, The Gathering Storm, signifies the tipping point that these issues led to that wept away our entire code base. To be honest, I haven't read the book, The Gathering Storm. It's a book in this Wheel of Time series from Robert Jordan. It's on my list to read, but I haven't gotten around to it yet. But the title fit perfectly with what I want to explain here. This storm literally blew away our entire code base. Let me tell you how. Remember that I said we had this microservice architecture, and every component had its own repository? So that meant that if you wanted to deploy to an environment, to have a fully functional application, you would have to go into every single repository and run a pipeline to deploy that component to an environment. Not only that, If you were working on component A, you wouldn't know if there had been a change to component B in the meantime. So you wouldn't even know if you were working with an up-to-date application. And to make matters worse, if you had a story where you had to change multiple components, your code changes would be split out over multiple merge requests. And you would have to make sure, as a reviewer also, that you knew, okay, so change A in component A, that corresponds with change B in another merge request there, and in another one there. And I have to keep them all in my head while doing the review. And I also need to make sure that we merge them all together, because if only merge one thing and the other thing doesn't merge, then we still break the application. So it was a nightmare. Well, if you're working with a couple of microservices, you might be able to do it that way, I guess. But we had, I think, about 50 microservices, and then you can literally see that storm cloud brewing. So we needed to solve this. Once again, a couple of ideas presented itself. The first one was, let's create a separate project where we can deploy a pipeline that would deploy all of the components as child pipelines to a specific environment. That was the first idea we had. And it helped with the deployments. Great. But it didn't solve any of the other issues. So we went back to the drawing board. What else can we do? And then someone came up with the idea of, what about using a monorepo? Basically, putting all of our code into a single Git repository, but deploying them all as separate services. And that meant changing our entire code base. We had to go from all these different repositories into a single repository, and we had to change our way of working as well. But it also solved nearly all of our problems. Because if you were now working on a feature where multiple components were changed, it meant that you needed only a single branch where all of these changes were in there. So a single branch and also a single merge request. Awesome. And it also meant that if you were synced with the main branch, your environment was always up to date. So this was awesome for us. It was a major change. It was huge. And we went from this storm cloud of microservices that were spread out into a single monorepo that helped us really move forward in our development process. But not all changes need to be this big to have an impact. Some changes can be small, like a spark. And the spark is a reference to the Hunger Games Book 2. The first part of the Hunger Games Book 2 is called The Spark. And here you see that Katniss Everdeen's actions at the end of Hunger Games 1, where she wants to eat the berries and defies the rules of the Capitol. That sparks the revolution throughout Pan Am. And you see that people are inspired now to do other things than to revolt against the rebellion of the Capitol. So in this chapter, we're going to see how a small change that we make sparks our revolution towards story-based releases. Let's dive into that. So with our monorepo, we could now, with a single pipeline, deploy the entire application to an environment. Awesome. But this pipeline built every single component in each pipeline run. So it meant that it was very slow. And since we only had 1 or 2 dev environments per team, it meant that when the teams were working in a sprint with multiple stories in a sprint, they lost a lot of time waiting and asking, can I use dev environment? Can I use the dev environment? Are you still busy? Can we share maybe? I don't know. It was horrible. We had like thousands of messages every day going through the chats where the people were asking, is environment A being used? Is environment B being used? Yeah. So we needed to figure out something to solve this. And we solved this when we started using Helm charts in combination with Kubernetes. For those of you who don't know what Helm is basically a package manager that allows you to keep track of the versions of your build components. That's what we use it for. It helped us to say, okay, we already have these built versions, so now our pipelines only need to build the components that have changed on that branch. And for all the others, you just use the version of main. And once you merge your branch in, once you merge your changes in, that version number gets updated automatically. And then if the other branches sync the main branch into their branch, they're automatically up to date. So our pipelines became much, much faster with this. And this actually was the spark that I needed to implement feature namespaces. And you're thinking, what feature namespaces? What's that? Allow me to explain. I like to explain Git with the tree. So if we look at the tree, we see that we have our tree trunk, which is our main branch in Git, right? And what I wanted to achieve was that every branch that we would make from main, so every story branch or feature branch, whatever you want to call it, every branch would have its own dev environment. But then what's the difference with the dev environments that I already had? I mean, remember, I said we had these dev environments per team, right, that we set up earlier. The difference here is that these dev environments were static and hard to maintain. And what I wanted to achieve was, with our move to Helm now, I wanted to expand our pipelines to automatically create and clean up dev environments, feature namespaces. This allowed our teams to dynamically create a branch per, an environment per branch that they had. These were short-lived environments that were also automatically cleaned up when you merged your branch. Which meant now that as a team, you could test your changes in isolation of other teams that were working on changes, but still with a fully functional environment, a fully functioning application. And these environments were cleaned up automatically at the end of your merge request as well. So we could now build up to 30 dev environments, whereas we had the 3 before. And these were easy to maintain because they were dynamically created and cleaned up. So that was awesome. And so, with the small change that we made to use Helm charts, it sparked our revolution to create these dynamic, short-lived feature namespaces. And this revolution brings us to the final leg of our journey. Because we need to get to that castle. And in order to get to that castle, we have to fight the Battle of Hogwarts. Now, I don't know who has seen or read the Harry Potter books. I'm expecting who hasn't seen. Maybe I can better ask who hasn't seen the Harry Potter books or read Harry Potter books. I don't know. For those of you who haven't, the Battle of Hogwarts is the last battle in the stories, and it was a battle long coming, and it required a lot of prep actually, because in order to defeat Voldemort, Harry first had to destroy several Horcruxes, pieces of his soul, and without destroying these Horcruxes, it would have been impossible to defeat Voldemort. And this ties in perfectly with our journey as well. Because we needed to overcome these challenges that we'd overcome up till now. Without solving all these issues that I've explained up till now, it would not have been possible to do story-based releases. We're not quite there yet, but we needed to go through this journey to get to where we are now. And we need to fight our final battle to get to story-based releases as well. And for that, let me go back to this overview that I've shown you multiple times now. This overview is actually incomplete. This is an abstraction of only the components that we create, update, and maintain as a team. But for our application to actually work properly, we need it to connect to external parties. We needed to connect to other partners so that it actually can work. And up till now, I had not taken this into account. Why not? Well, if you do releases every couple of months, month, or every 2 weeks, then it's quite easy to plan in a full end-to-end test with your external partners as well, right? You can plan those ahead of time, and you can schedule those and do them regularly in that way. But to do a full end-to-end test with the external parties for every single story that you pick up, is actually way too much work. You don't want to do that. So does that mean that we shouldn't do story-based releases? Have we done enough? Could be. I mean, for some projects, the answer would be yes, that's enough. But in our case, the client wanted to see that it was possible to do story-based releasing. Okay? Now, an extra challenge that we had was that our dev and test environments, or our dev and test clusters, could not communicate with the outside world. Which is why we did our tests with the external parties only on our ACC and prod. Well, we didn't do the tests on the prod one. We did the external parties tests on the ACC cluster. So this meant that I needed to figure out how can we shift this end-to-end test to our dev and test clusters while we can't really actually communicate with them. So I started asking questions. What risk are we trying to mitigate here? What are we trying to achieve with these tests? What's the goal? And the answers were actually quite simple. We want to make sure that if we make a change in our code base, that we don't accidentally break that entire chain of working, right? You want to make sure that you don't accidentally break something. And you want to make sure that that keeps on working over time. So we needed to figure out some way to do that without actually communicating to these external parties. So I suggested, well, why not capture the message that we would normally send out to the external parties in a so-called test catcher? And what we're going to then do is we're going to validate the entire content of that message in our tests. And these validations are based on an actual end-to-end test that we did with our external parties. So you know that if a validation now fails, you've broken your connection to the external party. And this meant that we now had end-to-end confidence on a dev and test environment as well. But I hear you thinking, yeah, but great, but what if you actually change something to that connection? Or what if you change something to that message that you're sending out to your external parties? What we also did was we allowed our dev teams to deploy their feature branch to an ACC namespace. Because they would know before picking up the story whether it was a story that would touch that connection, whether it was a story that would change that message. So that they could plan ahead of time, saying, hey, in this sprint we're going to pick up the story, and they could, in that sprint, deploy their branch to an ACC namespace and test it end-to-end with the external parties, giving them the full means to do all of their testing in sprint. So basically, that allowed us to reach story-based releases. Because teams could now pick up a story from the backlog, do all of their testing in sprint, merge it in sprint, and have that story go through with pipelines all the way through to production. How did we get here? By using test strategy storming to come up with what's relevant for testing, using value stream mapping to determine our development process, by restructuring our code into a monorepo, and by creating dynamic, short-lived feature namespaces, and by using test catchers to validate our end-to-end tests. Now, this has been quite a journey. And before I leave you all today, I want to share with you two of the most important lessons that I learned along the way. The first is the importance of the journey. I knew at the beginning when I started this project that I wanted to have feature namespaces, that I wanted to have test catchers. But the teams weren't ready for it. You can jump to the end of your journey and find yourself alone there. If you do not bring along your team with you, if you do not let them experience the steps and let them experience the journey with you, you won't get there together. The journey is just as important, maybe even more important than the destination. The second is the importance of experimenting. Like I said, these teams were open to experimenting. They were not afraid to fail. They wanted to try things, and they said, you know, if it breaks, we'll fix it. We'll figure something out. We knew we wanted to get towards story-based releases, so we just went, every change that we made to our process, every step that we took was towards that end goal. And we failed multiple times along the way, but we changed, and we learned from that. If you do not take that next step, you'll not improve. You'll never learn. So you need to take that next step. So this has been quite a journey, and as you all leave today on your own journeys, I hope you enjoy the journey. But I hope, most of all, that you have fun experimenting. Go out there, try it out. You know, have fun, enjoy yourselves. Thank you so much. Questions?
A presentation and amazing theme and design.
Thank you.
I have two questions,
yeah,
but they connected. When you go to this dynamic environment, what the price of support all this mess, because it's a lot of environments,
yes,
and what's the average time for life of these environments? Like it's day, weeks, hours?
So what we did with these dynamic environments were we made their resources very, very tight. So what we said was we have our stubs and our consumers that don't change that often. Those are like things that are shared, right? Because they don't really need to change. So we had that in a separate namespace where all of these feature namespaces could then connect to. So, and then we also said, okay, we're gonna make those environments like very tight. So if you needed, for example, 650 MB of memory or RAM, whatever, we would set that limit on that container to be as small as possible, so that we could have as many namespaces as possible, right? So we juggled with, okay, what are the resources that we have, and how can we create as many environments next to each other as possible with those resources? The second part was, oh yeah, how long they lived. We have stories that are done within a couple of hours. So you create a branch, you change your code, you run the pipeline, it deploys the environment, you runs the tests, and then you say, okay, I'm done, I'm going to merge, and then it cleans up the environment, and it can be like within an hour. Some stories you're busy with an entire sprint, right? So then you'll have a namespace or an environment that lives for an entire sprint. So yeah, there's that range and that flexibility there. But the purpose is to have short-lived environments. So if a merge request is open for longer than a sprint, we start asking questions. Why is it open for longer than a sprint? Is there a problem here? Is there a problem with your process? Are there impediments? So yeah, the idea is to have it within the sprint. Should be gone.
Thank you.
Yeah. See lots of hands.
Thanks, Mazin, for the wonderful presentation. Yeah, so so if we go to the last part of the presentation, right, where you have these different environments, right? Mm-hmm. So I'm assuming the ACC is a kind of a pre-prod environment, right?
Yes. Yes.
So ACC and prod, the clients have your access, and
yes,
before that.
Yeah.
So I was wondering, could you have used the feature flags as well for the ACC account on the ACC and just have the feature deployed? And
yes,
just have it just for specific customers.
So when you have bigger features, that's what we do as well. So we have feature flags for bigger features. But what we also say is, if the story impacts that the message going to the outside, we want to make sure that we're not breaking something before we merge that story. So before merging, we wanted them to deploy to an environment where they could connect to the external parties and check that it's working. But before you do that, you first check that our initial tests, you know, on our environments that we set up with the test catchers, for example, that they already run green. So we know that, okay, we have trust that our validations up till now are working. We just want to make sure that because it is a change of that message to the outside, that we don't merge something into our main branch that could potentially break. So that's why we did that in that way. And of course, we also use feature toggles for larger things so that you can still merge smaller things in, and enable that feature only once the entire feature is done. So it's using both worlds.
That makes sense. Thank you. Yeah. Okay.
Yeah, in the back.
Hello. Yeah, thank you for this wonderful session. But so there is a question like if you deploy to prod and there is a bug which is critical, so in that case we want to hotfix that, right?
Yes.
Because this process will at least need a day or or 4 to 5 hours to complete all the testing, right? And there might be some complications as well. So if I want to do an hotfix, how would be the strategy for that?
Yes, good question. Because this is a discussion that we also had internally as in our teams as well. And up till now, any issues that we've found on prod, the agreement was, hey, if you can fix it within 3-4 hours, then we're fine as a client. And we said, well, our namespaces, the testing and everything is done within an hour, so we can run through that entire process within an hour. So they were fine with it. But we have had discussions, what if it's such a critical thing that we want to circumvent this? Well, then we'll have a hotfix process where you don't need to go to a feature namespace directly. If you already know this is exactly what we want to do, you can go directly, you have a shortcut path that you can take. But these are discussions that we had, and we've never taken that shortcut path because we want to have that confidence that the change that you're making to hotfix it doesn't accidentally break something else, right? So we said, okay, that hour time we have, that's good enough for us. But yeah, it would depend on another project. If that's not good enough, you might need to do something else. I don't know. Does that answer your question?
Yeah, I was thinking like we can actually use the feature branch to build the, let's say, pre-prod or SAC account environment. So there we can test it and then merge that, deploy that, and then back merge the.
Yeah, there's multiple possibilities there, right? But we branch off of main, and main is the one always on production. So since we branch off of main, then it's a very small chain, goes through that chain quite quickly. So for us, it wasn't an issue.
Yeah, one more thing, what's the difference between the Helm? I don't know enough about it, and Helm versus the GitLab tags. So we use GitLab tags to basically trigger the pipelines.
So GitLab tag is something that you add to your repository saying, hey, this is like in this moment of time where I want to tag my code base, right? What Helm does, it tells you per component, so Helm allows you to deploy to Kubernetes quite easily. And we have an umbrella chart where we say these are all of the components in this use case or in this application. And for each component, you can give a version number. And that version number or ID or commit hash, whatever you pick for that version number, you can change quite easily. So once a component is changed, once you merge that into main, that merge commit hash is the version number we use in Helm. So that allows us to say, hey, our main branch, our main Helm deployment picks up these commit hashes to deploy to every environment, and it's the same thing that we can propagate through the different environments. And when you sync your branch, you'll see that, oh, you haven't changed component B, you have only changed component A. Guess what? Component B has a new version number now. If you update your environment now, you'll have that latest thing on your environment as well.
Yeah, good. Thank you so much.
Yeah. There's a question over there. I don't know, I'm sorry, I'm ignoring this part of the room.
So thank you for the presentation. It was very good.
Thank you.
One question. Are those environments living in cloud or you have in-house?
Cloud, yeah. So, well, it's an in-house cloud.
Okay. How about the costs? How you have calculated all these costs and you convinced the stakeholders about these?
So luckily for our client, they said, we have these resources available for OT, for development work and testing work. And what we did was squeeze those resources as much as possible to get as many namespaces out there as possible. That's what we did. And for us, luckily, they said, okay, if you need a little more resources for your testing work, that's fine. As long as we try and manage that, as much as possible. By squeezing that namespace, like I said with the first question, by making them as small as possible, we get to have namespaces that are very, very tiny, but still reflect the entire application. So yeah, once in a while we run into out of memory issues, but then you know that it's not application related, but then you change that resource and then it's fine. Yeah. Yeah. You have a question on that side?
Hi, amazing presentation, first
Thank
of all,
you.
thank you. I'm just curious about the quality gates along this journey, like from the beginning till the end. How do you, in such a dynamic environment, how do you decide what shall and what shall not pass?
You shall not pass. Yeah, good question. So because we had 4 dev teams, we would have weekly sessions with the leads. And as a QA lead, I was allowed to say, hey, this is something that you're not allowed to break. So things like Sonar, you're not allowed to merge if you have Sonar issues on your changed codes. So we try and figure out what's the best way that we do not impediment the teams too much, but still add in that quality where we want to write. And it was a slow process getting in there. So first we added in Sonar only on the main branch. We saw, oh yeah, guess what? That's not going to work because that fails. So then we said, okay, we need to analyze only your code changes. And first we just showed them, hey guys, listen up. So if you see now that the Sonar is in there, you see now that these changes that you're making, that they aren't good changes. Next sprint, we're going to turn it to blocking so that you know that you'll have to adhere to these rules before you can merge your code in. And like that, we did Sonar, we did mutation tests, we did OWASP dependency check, and things like that. We kept on adding them in so that slowly people got used to the fact, oh wait, we're getting all these quality gates in there. And it became part of their way of working by adding them one by one slowly in there.
And if I may, the follow-up question.
Yeah.
It's applicable for the for each individual stage, or to have the different sets of rules, or just one rule to rule them all?
I love your references. It is, so we can have different rules and the different stages, yes. So for example, on the merge requests, we have a different set of conditions than on when you have on the main branch. For example, we know the Sonar of our main branch is going to fail. So we said, okay, on the merge request, we're going to set it to only look at the changes that you've made, and it will block you if there's a failure there. But on the main branch, we said, hey, we know that we have technical debt there, so we're not going to make it fail, but it's going to report these failures so that we have a backlog of technical debt stuff that we need to pick up. And so in that way, we have a different set of rules for those 2 different types. And those are actually the only types that we distinguish between now.
Thank you very much.
Thanks. One more at the back. I don't know how much time we still have left, though. But yeah.
Hey, I was wondering how painful it was to migrate from multi-repo to monorepo. And if you had to pause like the dev and say no more merge requests for a few days during the migration?
Actually, I was thinking it would be very hard, but it was actually quite, well, not entirely painless, but so what we did was we told all the devs to keep on working on their components, and then in the meantime we did like a shadow monorepo that we started doing where we would sync their changes to. And in one sprint, we work with SAFE, so Scaled Agile Framework. So we had an IP sprint, and we told them, okay, this IP sprint, you're not going to do code changes. You just do innovation stuff, figure something out. And that IP sprint, we said, okay, we're going to do the last syncing of those different code bases and set that monorepo up with those last changes, and then we're done. So basically, it was blockage of one sprint.
Okay, thanks. And just to follow up, I know the monorepo, multi-repo is a big debate, but in your opinion, is it monorepo has more pros than cons in most cases?
For me, definitely more pros than cons. It increases our maintainability quite, like very, very, very much. Because if you want to replace something or something that's used through all your components, it's very easy to do a Control-Shift-F in IntelliJ, and then it goes, oh yeah, it's being used in all of these places. So I know that this change impacts these components. It took some thinking to get the GitLab pipelines working properly as well, but we figured something nifty out for that as well, so I'm very happy with that. yeah, for me, I would always go for the monorepo route now. Yeah.
Thanks.
There was one more at the back. I don't know what the time is. We're out of time, so last question, sorry.
Super quick. How much resource did you have to enable these test environments? Did you use a lot of dev teams, SRE, DevOps, or was it just in the test team?
Resources in terms of?
Like people.
People, yeah. So we had our dev teams, and we had 3 people that were doing all these other changes to the process. So me, an architect slash opser, and an actual ops engineer. And the 3 of us, we were working on all of these changes. So it was, yeah, it wasn't that bad.
Okay, interesting. Thank you.
Thanks. I think that was all the time we have left. Thank you so much.